All right, you maggots, listen up. Yeah, that's my MP3 player. I think it's a Salsa. Uh, it's 15 years old. I bought it when I first got here. But the reason that's in the frame is so I can tell one video from another when it's up in the folder. All right, I can see the thumbnail with the MP3 player, so I know that's the one I want to upload. Okay, that's why. I can actually give you a reason why. Now, this video is about glitches and self-resonance. Self-resonance. I notice when I pronounce a word, sometimes I feel like I haven't said it correctly and I say it again. That's because of my hearing's going, and I'm worried about getting Alzheimer's because everybody that I grew up with, all the men in my neighborhood in New Jersey, got different kinds of Alzheimer's, and I'm at that age now. So it worries me. And you got two presidents that basically should not. You got two guys that were president. One was president. One is president. Neither one of them should be anywhere near the presidency. That's my opinion. I'm a independent voter, just so you know. Uh, the first time I ran into self-resonance, and you might be in electronics your whole entire life and never run into a situation with self-resonance. So I'm in RCA, I'm in Life Test, and you got to picture these giant Bakelite racks with Bakelite uh, tube uh, shelving. There were Bakelite shelves with sockets, thousands and thousands and thousands of tubes. And I'm walking along, and I see a whole row of tubes, and they're cherry red, and that means the tube is running away. I know that. I know the tube is running away. Why it's running away, I don't know, but the entire rack is running away. So basically, the person takes the tubes down and they send them to be tested. They test them, they test good. They have them checked to make sure all the parts are inside. Remember I explained to you, you could be missing a grid. Isn't. They have me check the voltages on the tubes. Right? Blah, 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 blah. So this goes on, and then I talked to the head, the lead tech, Joe, and I said, Joe, they got me working on your tubes down the back. And he's sitting there smoking a pipe. And he's like, yeah. I said, you just put them up. I said, they're going cherry red. And his eyes always open wide, and his eyebrows would go up. He goes, oh, no, really? I go, yeah. I said, they took them down and they sent them out and got them tested, and they made sure all the parts were there. I said, but they're still running away. And that's what I was taught. They're running away. So we go down there, and before we go down there, he grabs this little box on this bench. He grabs this thing that's got a handle on it that goes into a meter, and then another black thing that comes out the top. It looks like the wand that they use at the airport for metal detection. When they check your person, when they actually check you, that's what it looks like. He takes that in this small box. And we go down there, he looks at the tubes, and they're glowing cherry red again. He throws the power off to that bank. He flips the shelf. You take the shelf out and you flip it over, and it's sockets. And it's got, on the back, it's got all kinds of bus wires on the back, for your plate, your cathode, your grids, and there's resistors at each tube socket. And he's looking it over, and then he knows he's got another thing with him. He makes sure he's got the right values of resistors. And I said, well, I've already checked the voltages for that tube. It's all correct. So he takes out this box, he opens it up, and out come these little things. See, I forgot to tell you that on the last video. The things that look like rabbit turds with the hole through it. And he unscrews. There's the garbage truck. He's distracting me. He unscrews the wire for all the grids of the tubes, of 10 tubes on the rack or on the shelf. And he puts one of those on each one. And then he turns it over. And then he fires it up, and they don't run away. And I, right away, you know me, right? What did I say? So what does that little bead do? That's the first time I saw these little beads. We call it a bead because it is a bead. It's got a hole through it. Before I called it a rabbit turd. But anyway, he goes, I don't know. He says they told him to put them on the grids of tubes that go cherry red. I was like, oh really? So I go back. I have the box. I open up. I'm looking at it. I realize it's ferrite material. And then I'm waiting for Kenny to come in. And I call Kenny, I'll use the engineer, and he quickly says, when you put that on the wire of the grid that goes to the tube, it becomes a choke. And it keeps any RF that's on the rack system from coming in and getting on the grid of the tube. See, we're running the tubes, even though it's an oscillator tube or it's an RF amp tube, we're running it just at DC, a destructive test. You run the test at a certain current through the tube for 100,000 hours. It comes down every 20,000 hours and gets tested. And we're life test. And we figure out how long the tube should last when it goes to the customer. So we're running it under DC. But there's noises that can get into the grid of a tube. It can be amplified by the tube, and it gets put back on the plate of the tube or the main B plus voltage of the rack. So the rack in the building has all kinds of noise on it from just the fact that there's all these wires running everywhere. So that noise can get in the tube, it can get amplified, and then the tube goes into self-oscillation at that frequency. And then the tube runs itself into the ground. It runs away. The biased resistors that are on the tube are set up to destroy the tube. So we already have the tube out of its parameters, DC wise. So if you put an AC signal in there, that poor tube's going to get red hot. It's going to destroy itself. But that's what you do. You put that ferrite thing, and that unit that he had in his hand. It's got a handle. It's got a tube. Just picture this thing here with a handle on the bottom here to hold it, and out the top is a black rod, and the black rod has a ferrite rod inside. It's got a diode. I open it up. It's got a diode inside, and what it does is any kind of oscillation that's near the handheld unit. It's an RF sniffer. Call it an RF sniffer. The meter comes up. It letting you know that there's some type of RF field, or the tube is getting ready to run away. That's the first time. That's the first story. That's RCA. Now let's go to Radio Shack. Okay, so Radio Shack sells an amplifier that goes up on the antenna of a house. This is years ago now. So it's on the roof, up on the roof, on the antenna, and it amplifies the signal from the antenna so it doesn't get attenuated through the wire. See, if you take a long run of wire and run it up to an antenna, even if it's shielded, as it comes down through the wire, it gets attenuated. So at the other end, you might have very little signal or no signal. But if you put an amplifier up at the antenna, it's a whole different thing. Now, I want to tell you real quick about the antenna amplifier. You send DC voltage up through the center lead of the shielded wire. It turns the amplifier on and powers it. So the ground and the center lead of the shielded wire from that antenna is used to put the power up into that amplifier. Now, on that same center wire, it comes down and the RF gets coupled off. And it gets coupled in on the wire up at the antenna with a capacitor, and it gets coupled off at the bottom. And that's how they get the wire, the center conductor of the wire, to do two things. It sends the voltage up to the amplifier, and it also lets the RF signal come down. All right, now, what goes wrong? All right, so the amplifier is sitting up on the antenna, and it's Radio Shack, and after a while, a capacitor starts to degrade, or the circuit board gets fuzzy, or whatever happens, the amplifier, it's RF amp, it's really running hot. It goes into self-oscillation. And the TV set might still work. The TV set, you'll never see the fact that transistor is oscillating at a certain frequency. But what happens is the aircraft flying in your area of your house, their instruments, this is years ago now, one of their direction finding equipment goes berserk in this one spot. So they mark it down in a journal. And then at some point the FCC goes out and drives around the neighborhood, and then they knock on the door and tell the person they located that it's the RF amp up on the antenna. And they red tag it. They tell the owner of the house, don't want that amplifier or on that antenna, get it fixed, or we'll be back and you'll get a fine. So Radio Shack sent a memo out to the different stores to pull that amplifier from the shelf because it was prone to self-oscillation. All right, so I hope you got that. Now, when you build circuits on that wireless proto board, hopefully I don't have to show you what a wireless proto board looks like. You tend to use wires that are a little longer. And anytime the input of a transistor that's running hot and the output of the transistor, the two wires get too close together, that transistor will go into oscillation, self-oscillation. The other reason it'll do is the wires are too long. You ran it the wrong way on the proto board because the wireless proto board is not meant to be used for RF. You can do it, I do it, but you better know what you're doing. You better realize that something's in oscillation before you start chasing your tail or going down the rabbit hole. But that's one of the problems with self-oscillation. I gave you the tubes can run away. Transistors up on the roof in that power amplifier can go into self-oscillation. When you build a circuit, if you put an input near an output, it can go into oscillation. Now, deglitching. Every IC, when it switches, when it's counting, when the flip-flop's flipping, when the gates are going from high to low, they draw current, little tiny amount of current. Now, in a flip-flop or a gate, a decade counter or something like that, all the flip-flops at a certain count flip at the same time, and they draw a lot of current, and those spikes go ringing through the B+. And if you don't have deglitching caps, and deglitching caps are 0.1s or 0.01s on each chip to ground, that count can go down the line, and between when an IC is switching from high to low or low to high, there's an analog spot in between. When it's switching between a ground and a high, there's a little region where if noise can get in there, it'll count it. So in the case of the Huff and Puff, I built the Huff and Puff. I built it just like the person said, and it was working, but it was acting weird. And I started thinking, you know what, let me put some deep glitching caps in. And I actually had to put them across the ICs. I tried them first on the B+ to ground. Didn't work. It had to actually be across the ICs. And you got the high-speed counters, and they will count. They will count high speed. You will get a reading that's sort of correct, but it won't be as stable as if you get rid of those counts that are getting out on the B+ and getting in another IC. Also, the chip itself, as it's switching, if it pulls too much current, or it does pull current from the B+, and the B+ dips too much because the run from the power supply is too far without a deglitching cap, it'll count those extra counts. So one flip-flop is being triggered by another flip-flop, and the chip will seemingly work. You may have what you consider really good results, but then if you put the deglitching caps in, the circuit works so much better. These are the concepts and problems that nobody else talks about because they never had to really design or build anything. And the designer and builders don't do, they don't hang out in conferences. They don't always tell what they know. They could be a scumbag like that. Some engineers don't want you to know what they know. Now, I told you I work with this guy, Ken Recor, and he was constantly teaching me. And the other guy started getting jealous. And he started teaching them, and by the next day, they forgot what he taught them. It was sad. It was just sad. These guys, they come out of World War II, and they didn't even know what they wanted to do. And they went over to a bar, and somebody came in through the door and says, hey, RCA's hiring. So they all go over there. Now, RCA is switching from military to home electronics after World War II. They're starting to put television sets in people's homes. And they're making all these extra tubes for AM radio, for the government. So they need all these extra people. And they do on-job training. But what they do is they teach the person how to do one job. And most of them don't even understand what they're doing. They're just going through the motions. Well, this is what they showed me. And then they would say that to me, like, just show me what to do. And I'm like, it's not that simple. But in their mind, if RCA could teach them to do a job, I should be able to. But we were starting to get transistorized equipment into RCA for testing, to do our tests. And these guys were lost. And you sit them down and you start explaining how a transistor works. They don't want to hear it. They don't even really understand how a tube works. And they have to light a cigarette up and they want to break. They got to go to the bathroom. They get really nervous because they know they're almost 50 years old. And they're the kind of guy that I learned all I need to know. I learned it all. I don't need to know anything more. Then the company starts closing down and they start having jobs available. And these guys, now they want the new job, but they don't want to learn what goes with the job. It was the worst example of that was, in order to become the shop steward, in order to have, you have perfect, you can't be laid off if you're a shop steward. So we had Tony, for all the years we had Tony, he was our shop steward. Now suddenly everybody's running for shop steward. And if you're shop steward, you can't be laid off. So everybody runs for it. So part of Tony's job, he has to know how to do welding. So every morning they test 5 guys welding. Heliarc, you had a Heliarc machine, you had to actually weld, I believe it was aluminum. And these guys would walk in there and they'd fill out the application for the job. And they put down that they knew how to weld. They basically knew how to use a Burnsomatic torch if they were lucky. So every morning, 4 or 5 guys would come up. Oh, I didn't pass, and they let them keep their sample of the thing they tried to weld. And I know I hate welding. I did brazing. I don't like it. I don't have the finesse. When I would braze a part or solder a part, or I have a fixture holding it in exact alignment, and I have it cleaned up and fluxed up, and I hit it with some heat. And I hit it with my solder, tinks, whatever the solder was I used to use. It was a higher temperature silver solder. That's how I would do it. But in RCA, you had to be able to weld steel. All this stuff that you never would actually do, but that was part of the requirement in the union. But there were over 120 guys that tried to get Tony's job, and none of them could weld. And Tony could weld. And it was hilarious stuff. Every day, the company had some guy go over, an independent guy, that would test their welding skills. And it was laughable. And some of the guys would come up, well, I gave it a shot. I knew I couldn't weld, but I really wanted to, you can't be laid off type of thing. They were trying everything to stay in that place. And I took my layoff. Really? Okay. And then the guy gives me the paper, Gordon. He gives me the paper, and he's all upset for me. And I go, okay, Gordon. I said, I was laid off from McGrath's, and the Gold Brick threw me under the bus. Won't go in that story. But anyway, I was laughing, and poor Gordon's almost ready to cry. I'm going to really miss you. I'm like, yeah. I said, well, both of us will move on, But they did. They took a box, and they put it by my bench, and they started filling it with all kinds of stuff. And then they sealed it up, and then Gordon walked out past the guard with me with the box. They gave me a bunch of stuff from the place. Everybody gave me a little gift, some type of electronic part or something. But yeah, it's pretty funny. But one of the things was the tubes that would go into oscillation. And that's one of the things you would look for. And I said they had this wand, and you'd put it near there, and the needle would come up, and you knew that's what was wrong. But we had high voltage regulator tubes. They were 6 BK4s. I think I'm right with the number. Had this giant unit. When I worked on it, I had to wear a lead vest. I had a badge on for radiation. Well, what they did, I told you down in Woodbridge, they took the gold out of the 6 BK4. And when you put them on the tester, they'd run away. So they come up with a procedure where every half hour you crank the voltage up a little higher so you can get the tube to run. Now in Woodbridge, what they did, underneath, they went and put extra resistors on to change the bias. I'm like, I'm looking at these resistors, and these aren't on the spec sheet. So of course, the dandy, we got to get those off. So as soon as we took them off, the tube started running away. So I knew the stories from other engineers that down in Woodbridge, they were starting to dummy up the tubes, and they were getting a bonus for doing that, and then they would retire. So I knew the 6 BK4 was one of the tubes. So I went home to my father's tube caddy, and I went in there, and there were 2 6 BK4s. I come in next day. I went through the guard. I had to log them in as my tubes. Took them upstairs, put them in the fixture, turned it on. They didn't run away. So whenever the bosses would start on me, I would remind them I bought 2 tubes from home, RCA tubes. They didn't run away because they had gold in them. And the gold plating increases the emission. If you gold plate the grid of a tube, it allows the grid to have more control over the electron stream from the cathode to the plate. If you don't have the gold on there, it still controls, but not as much. So under certain circumstances, the tube will run away, especially a high voltage rectifier. Now, high voltage rectifier is used on the high voltage circuit, and what it is when, like, you're watching a Western, and it goes from a daytime scene to a nighttime scene, all that extra high voltage gets pumped into the high voltage regulator. And you'll see that thing if you're watching it at a TV set. You'll see it. It's called what the hell? There's like an eye down at the bottom of it. Let's call it a target. You can actually see the plate shooting down on the cathode red, and you can see in the dark scenes that gets brighter, and the tube has to quench the high voltage to get rid of it or attenuate it when you go to a dark scene. I think that's it. All right, that's it.